Hello, everybody, and welcome to our third week here in the virtual classroom. To try and make it seem a little bit more like we were in my room at school, I decided to throw in some Pepsi stuff in this video. What you're looking at is the world's largest Pepsi sign. The top of the bottle in that sign is 70 feet off the ground. Some of you that were going to take the music trip to New York might have seen this if you were on that trip. It's located in Long Island City, Queens, right across the river from the United Nations. And just a hint, if you're ever back in New York on your own, one of the best views you can get of Manhattan is to take the subway over to Long Island City, find the Pepsi sign, and turn around and look at Manhattan from there. It's a gorgeous view of the skyline, way better than anything you'll actually see in Manhattan. But Pepsi doesn't have anything to do with our lesson today. Today is actually a day when you get to learn some stuff that's totally new. You know, an awful lot of what we've done in advanced algebra just reviews and expands on things that you learned back in Algebra 1 or even in junior high. But I'm willing to bet that for just about everybody, the things we're going to talk about today really are new. What we're going to talk about today is what are called exponential equations. That's something that I alluded to back when we were doing the interest problems last week. An exponential equation means that you have an equation where the variable is an exponent. So instead of saying something like x squared, you're going to say something like 2 to the x. Here you can see several exponential equations. We start with 2 to the x equals 128. And then I have 3 to the 5x minus 2 power equals 1,348,201. And finally, 1,000 times 1/2 to the x equals 1. We're going to figure out eventually how to solve all of these, but we're going to start with some of the simpler ones, which is basically what the first two are. Sometimes you'll have exponential equations that are really pretty simple, and you can either solve them by trial and error or just using your common sense. Both of these, if you think about it for a minute, you can probably figure out what the answers are. What I can do for 5 to the x equals 625 is just take different powers of 5 until I end up getting the right answer. And you can see down at the bottom, it shows you that 5 to the 4th equals 625. That's how I know that 4 has to be the answer to that problem. Something you should remember from what you've done before is that anything to the 0 power is going to end up being 1. And that's why 3.27 to the 0 has to be 1, and the answer in that problem has to be 0. Well, the two problems we just did are things I could do in my head. Most of the time, exponential equations are not things you can just solve through common sense. So what we do instead is we use a process called logarithms. You probably have noticed that almost any calculator that costs more than about $5 is going to have a key on it somewhere that says log. Log stands for logarithm, and we're going to be using that key throughout the rest of this chapter. Finding logarithms is kind of like playing Jeopardy with exponents, because what we do when we find a logarithm is we're asking what's the power that we need to raise something to get a certain answer. It tells you here that a logarithm literally is the exponent to which you raise some base to get a given number for the answer. So I'm giving you what you start with, I'm giving you the final answer, and you need to figure out what's the exponent that we have to find. So for instance, if I said the log base 5 of 25, which is how I read that notation, by the way, log base 5 of 25, that's saying 5 to the what gives you 25 for an answer. It's just like if I had the exponential equation 5 to the x equals 25, And if you think through that for a minute, you should be able to figure out that the answer is going to be 2. The log base 5 of 25 is 2 because if you take 5 squared, 5 to the second power, you get 25. So before we figure out how we're going to do this with a calculator, I want you to look at these 3 problems and just use that common sense about what power do I have to take the little number to get the big number, and see if you can figure out what these 3 are going to be. And here you got the answers. The log base 2 of 8 is going to be 3. That's because 2 cubed, 2 times 2 times 2 gives you 8. The log base 3 of 81 is 4, and that's because 3 times 3 is 9, times 3 is 27, times another 3 gives you 81. And finally, the log base 10 of a million will be 6. You might or might not know that when you take powers of 10, it's the number of zeros that you get after 1 in your problem. So a million is 10 to the 6th power. And here's one more that I want you to look at and see if you can remember how this one might work. The log base 2 of a fourth. So this is the same as asking 2 to the what gives you 1/4. And the important thing is to think back to a couple weeks ago when we first started doing the online stuff, and we told you that negative exponents always meant that you flipped things over and did the reciprocal. Here, what the answer is going to be is -2, because that would be saying flip it over and square it. And it does turn out that if you do 2 to the -2 power, you end up getting 1/4. You can see I put a screenshot here of the calculator that's built into Google. And by the way, I had to think, what do you do since there's no negative key on there? And you just use the minus key, oddly enough. So I ended up taking 2 to the -2. It's giving me 0.25, which of course is 1/4. Now we'll get into how do you solve things you can't just do in your head, or for that matter, how would you solve things like the one we just did that you probably didn't want to do in your head. We'll get to that in a minute. But before we do, there is a really easy kind of question you're often asked to do with logs, and that's to change between exponential and logarithmic form. And the thing that's important is how exponents and logs are related. You can see at the bottom there it says that if a to the b equals c, then the log base a of c equals b. Now, what's going on there is that one of them has an exponent, the other one has a log, and what's really happening is the order of the last 2 numbers are being flipped around. So if I had something like 3 to the second equals 9, that would be the same thing as the log base 3 of 9 equals 2. You just flip around the last 2 numbers. So here's some questions that are a lot like what you're going to be asked to do on worksheets and eventually on your quiz. The idea is that you're supposed to write the first one as 5 to the something equals something, and similarly on the other two. So again, look at those for a minute and see if you can figure out the answers. And again, if you look at all 3 of these, you'll notice that all that's really going on is it's written as an exponent, and the numbers are the same, but I flip around where the last 2 are. So we have 5 to the third equals 125, 4 to the -1 power equals 0.25, and x to the z equals y. Just flip around those last two numbers and write it with an exponent. Here it's just asking you to do the same thing backwards. I'm giving you something that has an exponent. You're supposed to write the log base something of something equals something. So again, let's see if you can do that. And again, the important thing is I'm flipping around the last two numbers. That's why I have the log base 2 of 64 equals 6, and the log base 5 of 1 equals 0. So now we're going to talk about what do you do if you're trying to solve a problem that you can't just do in your head. This problem is asking you to do the log base 5 of 3,000. And of course that would mean the same thing as 5 to the what gives you 3,000. And while you might be able to do some powers of 5, you're not going to find any power that you know off the top of your head that's going to give you 3,000 for the answer. Among other things, every power of 5 ends in 5, so it's not going to be a whole number. It is, however, pretty easy to do, but to do it, you have to have a scientific calculator. You've got to have a calculator that has a log key. And if you do have a calculator with a log key, all I do is I take log 3,000 divided by log 5. Now, a couple of things that I'm going to point out to you when you're doing that. First off, it's log of the number that's written big divided by the log of the base, the little number. So it's kind of like you're reading backwards as you go through the problem. And secondly, you'll notice I very carefully closed the parentheses after the 3,000 before I did divided by log 5. You had to do similar stuff back when you were doing sine and cosine and tangent, and basically if parentheses open, you got to close them. So we did log 3,000 divided by log 5, and you can see an answer on the calculator there. Now, when you divide logarithms, you pretty much always get irrational numbers. You're going to get numbers that go across your calculator forever. And a real obvious question is, what am I supposed to write for the answer? In the real world, it depends, but when in doubt, if you put about 2 decimal places, you'll usually be good to go. So I'd probably say 4.97. So now let's see if you can divide logs to come up with an answer to these. We've got log base 18 of 4,173 and log base 6 of 100,000. The first one I again typed into the calculator on Google, and all you need to do to find that is just type the words scientific calculator right straight into the Google search box, and then you can never say you don't have a calculator because it is built in right there. I did log, it throws in parentheses, I type 4,173 and I close those parentheses, divided by log, and then I put 18 in the new parentheses. When you hit equals, you get your answer, and again, I just rounded to 2 decimal places, so we've got 2.88. The second one, I did the same thing, except I used the graphing calculator that's built into my computer. So I have log of 100,000, close the parentheses, divided by log 6, and here we would write our answer as like probably 6.43. When in doubt, you're never wrong to put more decimal places than that. You don't want to overround and make it too small though. So again, I divide the logs, and it's always kind of going backwards when I do that. So log of 100,000 divided by log 6, you got your answer there. You might notice if you look carefully, by the way, that I didn't close the parentheses after the 6, and this was actually the same thing that happened when you were doing trig functions earlier. If it's at the end of the problem, you don't have to. In the middle, you absolutely have to close parentheses. So the next problem looks completely different, but it's actually the exact same thing. It says 3 to the x equals 75,912. And all we do to solve for x when you have an exponential function is just divide logs, exactly like we just got done doing. What I'll do on the next screen is I'll show you this is the log of 75,912 divided by the log 3. That's because this is actually the exact same problem as log base 3 of 75,912. And so we solve it exactly the same way we would that one. Again, all I do is just divide the two logarithms, log of 75,912 divided by log 3. And here my answer is going to be 10.23. And so here's a couple other examples. Again, let's take a minute and see if you can work these two out. Solving both of these also just involves dividing logs. So log of 54,321 divided by the log of 6, we get an answer of about 6.08. Now, if you wanted to check that, you could haul out your calculator and take 6 to the 6.08 power, and you'll get an answer that's fairly close to 54,321. If you literally said 6 to the answer power, where you did the whole decimal and didn't round, it should be exactly 54,321. So yeah, it's just divide the two logs, you got your answer. A lot of times when people are trying to figure out how to do this, they'll kind of think to themselves, you do log of the big number divided by log of the little number. And that's not exactly right. It's log of the number that's by itself divided by the log of the number that's by x. And so here I do log 4 divided by log 444. It's the 444 that has to come last. And when you do that division, you end up getting about 0.23 for the final answer on it. So one more type of question we're going to take a look at, and here it says 5 to the 3x minus 7 equals a million. I'm going to have you just look at this for a minute and see if you can think what might end up going on, and then we'll show you exactly what you do. And I'm going to tell you what we really have here is two problems in one. We're going to divide logs, and basically then we're going to solve an Algebra 1 problem. So I start by doing exactly what you probably would have expected. I'm going to take the log of a million divided by the log of 5, and I get an answer. And I could either write down that answer, or better yet, just leave it on my calculator because we're about to keep going from there. So what I've really figured out here is that the exponent I've got to put on 5 in order to get a million for the answer is about 8.58. And that's why what I'm going to do now is I'm going to set that exponent equal to 8.58 and the rest of that number that I had there. And I've got to solve that equation. Well, if you think back to Algebra 1, that means I've got to add 7, and then I've got to divide by 3, and that'll give me what the final answer to this question is. Now, I'll be honest and say if I was doing a problem like this, I would not write anything down except the final answer. I'd start by dividing the logs on my calculator, which I did. And then I look at the exponent and I think, what do I have to do to get x by itself in the exponent? Well, I've got to add 7 onto what I already had, so I just type plus 7, enter. And then I've got to divide by 3, so I hit divided by 3, enter. And right there it tells me that the final answer to this is about 5.19. Again, log 1 million divided by log 5, find that answer, add 7, and then divide by 3. And here's one last problem for you to look at. We'll give you guys a minute to see if you can work out all the steps on this, and then we'll compare and see if you're right. And again, your key steps are going to be to divide logarithms and then get rid of whatever else is extra in your exponent. So this one I again did with the calculator on Google, and you notice I just did the log of 1,234,567. Make sure those parentheses are closed, and then divided by the log of 2. And after you've done that, you need to subtract 1 to get rid of that plus 1 in the exponent. You need to divide by 4 to get rid of the 4x in the exponent. And once you've done all of that, your final answer is about 4.81. So 4.81 will be the final answer for what x has to be. Occasionally I'll have somebody that tries to check an answer like this, and they do it by trying to take 2 to the 4.81 power. But that's not right. You've really got to take 2 to the power of 4 times 4.81 plus 1 and figure out what that whole exponent is and then take the power. 4.81 though, 4.80889, etc. is the final answer here. Now where this is leading, and it's the next main thing we'll talk about, is going back to those interest and growth problems and trying to answer the question when. We're going to try and solve for t in those problems. And the basic process will still involve dividing logs. It's just that because it's a little bit more complicated formula, there's a little bit more stuff you've got to do when you work with it. But it's still that basic problem we just worked out. But for now, what you want to know is that a logarithm, is the exponent you put on some number to get a given answer. You want to be able to switch between logarithmic and exponential form, and you want to be able to divide logs, both to figure out how to evaluate a log and to solve an exponential equation. So that's what you'll have on this week's quiz. I will be creating a separate video that goes through some of the problems people had from last week's quiz, and you might want to look at that as well. Have a good week.